What is microgravity? Microgravity, also known as zero gravity or near zero gravity, is the condition experienced by objects or people in orbit around Earth or in deep space where the force of gravity is greatly reduced. While gravity is still present in these environments, it is so weak that objects and people appear to float freely and experience a sensation of weightlessness. Microgravity affects many physical and biological processes. For example, in a microgravity environment, fluids behave differently than they do on Earth. In the absence of gravity, fluids tend to form spherical shapes rather than flat surfaces, which can have implications for things like fluid management systems in spacecraft. Similarly, combustion processes behave differently in microgravity, which can affect the performance and safety of engines and other systems. In terms of biology, microgravity can have significant effects on the human body. For example, without the pull of gravity, bones and muscles can weaken, and the cardiovascular system can change. The immune system can also be affected by microgravity, which can increase the risk of infections and other health problems for astronauts. Scientists and engineers are still studying the effects of microgravity and developing strategies to mitigate its negative effects on spaceflight. Some of these strategies include exercise programs for astronauts, specialized equipment for handling fluids and other materials in space, and advanced life support systems for long-duration missions. One of the most notable aspects of microgravity is the sensation of weightlessness that it produces. In this environment, objects and people are free to move and float around without experiencing the force of gravity. This can be disorienting at first and can take some time to adjust to. In addition to the effects on fluids and biology, microgravity can also affect many other physical processes. For example, the growth of crystals and other solid materials can be different in microgravity, which has implications for the development of new materials and medicines. Similarly, the behavior of flames and combustion processes can be different in microgravity, which can affect the safety and performance of engines and other systems. Another important aspect of microgravity is the challenges it presents for human spaceflight. Long-duration space missions, such as those to Mars, will require astronauts to spend months or even years in a microgravity environment. This can have significant effects on the human body, including muscle and bone loss, cardiovascular changes, and immune system dysfunction. Scientists and engineers are working to develop strategies to mitigate these effects, such as exercise programs, specialized equipment, and advanced life support systems. Finally, microgravity research has important implications for a wide range of fields, from materials science and medicine to engineering and astrophysics. By studying the behavior of physical and biological systems in microgravity, scientists can gain new insights into fundamental principles of physics and chemistry, as well as develop new technologies and treatments for a variety of medical conditions. Despite the sensation of weightlessness, objects and people in microgravity are still subject to inertia and other forces. This means that they can still move around and collide with other objects, but their movements may be slower and less predictable than they are on Earth. In addition to weakening bones and muscles, microgravity can also affect the way that fluids move through the body. This can lead to changes in the way that the body regulates blood pressure, fluid balance, and other physiological processes. Microgravity can also have psychological effects on astronauts, including feelings of isolation, disorientation, and anxiety. These effects can be particularly pronounced on long-duration missions, where crew members may be far from Earth and their families for months or even years. Microgravity research is not limited to spaceflight. Scientists can also study microgravity on Earth by using aircraft that fly in parabolic arcs to simulate brief periods of weightlessness. These flights, which are sometimes called vomit-comet flights, have been used for a wide range of research projects in fields such as medicine, materials science, and engineering. Despite the challenges that microgravity presents, many people find the experience of weightlessness to be exhilarating and even transformative. For some, it can be a profound and life-changing experience that helps to shift their perspective on the world and their place in it. The sensation of weightlessness experienced in microgravity can be misleading, as objects and people are still subject to the same gravitational force as they are on Earth. However, because they are in constant freefall, they appear to be weightless. Microgravity research has led to many important discoveries and advancements in fields such as materials science, medicine, and engineering. For example, microgravity has been used to develop new drugs and vaccines, study the behavior of complex fluids, and test new technologies for spaceflight. Astronauts living and working in microgravity environments must take special precautions to ensure their safety and health. For example, they must exercise regularly to prevent muscle and bone loss, monitor their exposure to radiation, and take steps to prevent injury from collisions with equipment and other objects. Despite the challenges of living and working in microgravity, many astronauts find the experience to be exhilarating and inspiring. For some, it represents the ultimate adventure, pushing the limits of human endurance and exploration. As space exploration continues to advance, the study of microgravity will become increasingly important. Whether for long-duration missions to Mars, the development of new space technologies, or the discovery of new insights into fundamental physics and chemistry, microgravity research will play a critical role in shaping the future of spaceflight and our understanding of the universe.